Hello, I'm Benny Skelton. I'm the president of Cyclone Energy Group. Cyclone is based out of Chicago, and our team is specialized in tall building optimization and energy performance. In my career, I've worked on dozens of tall and super tall buildings in a wide range of roles. I've designed new and retrofit mechanical control systems, created energy models, performed computational fluid dynamics studies, and mostly commissioned systems and even retro commissions from existing tall buildings. So excited to present here today. I want to acknowledge my team at Cyclone for all the incredible work that they do on a daily basis with all the buildings that we work with. And I'll hand it over to John.
Yeah, thanks, Ben. Yeah, same point for me. Obviously, I've got a great team of colleagues and professionals at RWDI, and obviously excited to be here and speak on this topic. I have 16, 17 years experience in performance testing, building commissioning for a dozen of those, but doing testing for the entire time. Again, I'm technical director of commissioning at RWDI and current president of the Building Commissioning Association, the Eastern Canadian chapter.
So John and I are not going to be talking about what constitutes a tall building by definition, or we're not going to get in an argument about whether an antenna or a spire would be considered in the overall height of the building. But today we're going to share some experiences that we've had working with new and existing tall buildings through the commissioning process. While tall buildings dominate the landscape of our cities, there are actually relatively few of them in the overall built environment. I got to work with the city of Chicago about 8 years ago on an ordinance and learned there's 450,000 buildings in the city of Chicago, for example, but less than 1% of 1% of those would be considered a tall building. So they're a very small percentage of the overall built environment. It's relatively safe to say as well that a majority of architects and engineers in practice don't design tall buildings on a daily basis, if at all. Even our codes and standards. So for building codes, the model codes, they're not built around how to build and design a tall building. So when you go to big cities, often those codes have different sections or amendments to a lot of the things in the code to address buildings at height. So that said, tall buildings are a lot of fun. They're a lot of fun to work with. They're living animals. They live and breathe differently than a lot of buildings, and it takes a lot of years of experience to kind of learn how to do that. So we're excited to share some of those lessons today. And, unless you're afraid of heights, these buildings are really a marvel to go into and be part of, especially during the construction process. And in a commissioning role, we're getting the building when it's getting closed up near the top. And no matter what your job is that day, it's hard to get on top of a building and not grab your camera and snap off a few shots of the scenery. It's pretty extraordinary. So our agenda, we're going to talk through several different challenges faced when commissioning tall buildings. The project schedule is one of those main things that we talk about in projects. That there are a lot of moving parts in the tall building. They move very fast, they go up very quick, lots of trades on top of each other. Even in the design phases of things, there's a lot of moving parts and things that have to be evaluated. The mechanical systems designed at height will go through a few things that you want to keep an eye out for or want to pay attention to that might be different than most buildings when you're commissioning them. We're going to spend quite a bit of time on air pressurization and ventilation. So that's definitely one of the challenges that we've run into in our commissioning process is how do we commission buildings for pressurization control? How do we handle ventilation? How do we handle things like odor migration through the buildings? We can talk a little bit about budget and design limitations and some of the experience there with contractors and engineers and architects working on these buildings and places you want to keep an eye out for. And of course, stack effect and the nature and environments of buildings are a huge part. They take in nature differently than most buildings do, especially a lot of these tall buildings tend to be a lot of glass or window type environments.
Yeah, and we're also going to talk about building enclosure commissioning because it's something within the industry that's underutilized, and of course there's a lot of lessons learned in of course commissioning for tall buildings, and that includes the enclosure as well. And I'll speak to some of those issues that can occur. The next is controls integration and sequences. we have to manage stack effect. We have to mitigate it, and we're going to do that through a bunch of different variables. But ultimately, on the HVAC side, through the controls or automation system, and some complicated sequences, right? So to have that variability and have that air control is hugely important in mitigating stack effect. And then we're going to talk about some of the existing building issues and challenges that we've seen. Obviously, if we're working from new construction and have a commissioning plan and process in place, then that's definitely going to be different than walking into an existing building and trying to root cause some of these issues and put together a practical mitigation plan and implement that in the real world.
So starting really with the schedule, tall building projects can go for years. They can be in design for several years and go into construction for several years. And I've worked on some projects that have taken 7 years from start to finish with our involvement in it to get there and then moving on. So there's a lot of moving parts though. And when it comes to commissioning specifically, some of the challenges that we come into with doing our work is that we might be doing some of the testing when the building's not fully enclosed. When you're working at height, you have a tower crane, you have skip units that go up the side of the building, and those often aren't taken down till fairly close to occupancy in a lot of buildings, and that can cause some issues when we come to testing things, especially on the air and pressurization side of the building. You really want the building to be fully enclosed before you do those commissioning procedures. And also when it comes to the schedule with all the moving parts, a lot of things can get neglected or maybe not even done up to the correct standard, especially when it comes to airside and waterside systems and the balancing of those systems. When we do a multifamily residential building and we're looking at the airside systems, we'll have toilet exhaust risers, kitchen exhaust risers, dryer risers for exhaust, and makeup air units bringing fresh air to replace that air and to help manage some of the pressurization and stack effect. When these things aren't, buildings not fully enclosed or systems aren't quite balanced, you're kind of beating your head against the wall, testing things at this early phase. You're maybe finding some functional issues, but you're not really getting the whole building as it's going to live and breathe. You want to make sure that you plan out your schedule with the contractor's schedule to make sure that you're able to test these things when it's ideal and it's the best possible time. On the air pressurization side and testing of those units like the exhaust fans, things like not having registers and diffusers and grills in place can cause issues with your test and looking at flow. So we see a lot of test and balance happens before everything's kind of a finished product like that, especially in multifamily residential where they're trying to get people in the building while you're still building it. It causes a lot of strain and access to the units to make sure that the local damper or local exhaust fan are on in variable systems is critical, and making sure that you have the correct percentage of those is a very important thing. One thing we run into a lot also is the spaces not being fully built out. So commercial office buildings are a great example. How do you test and balance something that doesn't, was built as a core in a shell, but doesn't have the occupants? So it's not been built out with terminal units in the space. And so one of the solutions there that we've done in a lot of our projects is have the ductwork be open on some floors to be able to test the air handling equipment. Controls are always a big area here, and the staging of test and balancing controls, I think, is really critical. And John, I think you speak really well to this point and kind of how the strategy and schedule with these go.
Yeah, for sure. So again, we have to have a cross-functional team early on. I mean, that kickoff meeting with the project team is extremely important. I can't emphasize that enough. That's when the entire team on the construction side, controls, balancer, have been procured. They're knowledgeable about the project, and that's when you really have you have that sit down, or at least virtually in our current times. It's important that you kind of go over what your plan is. Here's how we're going to do that. Here's why these sequences are important. Here's how we're trying to mitigate stack effect in this building. Here's all this key information. And now it's your job to go out and install it. And we're going to implement and verify. But at the end of the day, everyone needs to, that communication is extremely important as outlined, and going through those critical steps within that commissioning plan is key. I'll speak to it later as well in a little more depth, but scheduling is extremely important on those individual contractors that need to be need to be outlined and work together right away. That controls contractor needs to be on site to complete their work first, and then of course balancing happens afterwards.
And we want to make sure that as the buildings are becoming occupied, that things are working nicely. So we see a lot of times in the project schedule that people are going for a temporary certificate of occupancy while the skip units are still in the building. They want to put, especially multifamily apartment buildings, they want people in the building as quick as possible to generate the revenue on the investment. And this poses some dangers. But when it comes to the schedule, us as commissioning agents, we're not the construction manager. We're not setting the schedule. We're integrating into it. But a lot of times, our experience with the project needs to be outspoken to make sure that we're doing it. So a lot of times in our commissioning meetings, we're trying to dictate when the controls need to be done by, when the test and balance needs to be done by, so that we can meet the guidelines and the deadlines of the project. And then one other thing that we run into pretty frequently is, and especially when it comes to issue resolution with rolling warranty phases, a lot of the equipment warranties will start at startup. Once the factory comes out and does the startup, the warranty is now active for a year, or whatever the owner has purchased for the project. And the startups are happening, level 3, level 43, level 83. They're all happening at drastically different times. And even though they may serve a common system, when the issues start to arise, we have to be aware that we need to get these issues resolved prior to a warranty phase, because we start to lose support of the contractors at that point. When we're designing mechanical systems at height and we're going to commission them, we want to pay attention to certain elements. So some things that stick out in the mechanical system design that we want to pay special attention to are things like pressure breaks. So buildings often have heat exchangers for pressure control to keep the piping systems in certain ratings. When you're in the design phase and doing design reviews, or even in the submittal review, you're wanting to look to see if it's rated for the correct level of pressure that tier of the building is going to have. The engineer should know how to do this correctly, but it is something you can slip through the cracks. Somebody can get a chiller, for instance, where the condenser bundle isn't sized for the correct pressure rating, and it just gets missed. So you want to make sure that you're looking at these things as a second set of eyes. When it comes to the commissioning of these systems, like the pressure reducing valves are common in the plumbing systems for domestic hot water, domestic cold water, things of that nature. You want to make sure that those are set up correctly. You want to look at the gauges on them, make sure that they were treated properly. These are things that fail and can fail pretty quickly. They need to be rebuilt often, especially on the hot water side. So you want to make sure that they're set up correctly from the beginning, that the owner and the operator know how to use them and what to look for, because there can be some issues there. Anchors and expansion, again, it's a design element, but a lot of people don't go and witness the installation, make sure they're where they said they were. And I'll give an example in a minute of why that's important, to make sure someone else is looking at it. But you want to make sure that these systems are moving the way they're supposed to, and there's not a risk after the walls get closed up. Vibration isolation is something that comes into play a lot, especially when you have large mechanical equipment, and you might have a sensitive area below, beneath, or adjacent to. Again, I work a lot in multifamily residential, so the most expensive unit is usually the one at the top of the building, right below all the expensive equipment, that makes the most noise. And so having an eye that making sure vibration isolation systems are there in the design, that the submittals look right, and that in construction they're implemented. Because there are some tests that sometimes we'll do with acoustical engineers as well in the commissioning process to make sure we're mitigating any kind of vibration and noise concern. And then the last element that we like to look at is leak detection. When you have water up high, it finds its way down low, and it finds its way in a variety of different places. And again, and in the multifamily high-rise market of buildings, leak detection is absolutely critical to prevent millions and millions of dollars worth of damage to people's homes, especially a lot of tall buildings have pretty high-end living, pretty high-end finishes. And, we've seen buildings with multiple floors damaged and tens of millions of dollars in damage. We've even seen it in new construction where we're finishing things off and uh, nobody noticed over the weekend a pipe broke and a whole tier of apartments have to get new drywall and cleaned out and reviewed for mold. So a real brief example of an existing building, we worked on a chiller plant retrofit. Simple project, we're putting 2 new chillers in, taking 2 old chillers out, and everything got commissioned, went really well. And it was about 3 months later, in the middle of the summer, we got a call. This is a mixed-use building, has a commercial office in the lower tier, and high-rise goes up to 56 floors, and that's all condominiums. We got a call from the property manager in the commercial side that said, "Hey, we've got a noise complaint on the 42nd floor. They're saying it's this new chilled water plant that got put in." And I said, "Well, that's kind of odd. They're a long ways away because the chiller plant's on the 3rd floor and they're on the 42nd floor." And so we kind of didn't really believe them for a little while. I finally got invited up with another engineer and some people up to the unit itself, and we were in there, and this person had a severe noise and vibration issue. Their unit was completely unlivable, and we had an acoustical engineer look at it, and we just couldn't figure out like if it was coming from the chiller to a mid-band range or something, some kind of octave breakout mid-tier of the condenser water pipe that goes up to the roof where the cooling towers are, about 600 feet above the chiller plant. Well, we finally got the idea to open up the wall, so we had to get on top of an elevator car, cut open an opening. We found the picture on the left. You can see a 14-inch diameter condenser water pipe resting on the concrete, and the noise from the chiller was vibrating into this concrete and caused an issue. So we fixed it with some neoprene pads, but when we went out to put the neoprene pads on, I was helping the contractor, and I put my arm on it, and I moved the pipe about 6 inches. And I'm not a big person, and that shouldn't happen. And what we discovered was during the construction of this building, the anchors and the expansion actuators and guides weren't fully installed. And so this pipe was swinging quite literally. And we ended up getting a contractor on a elevator for a few months, and they went through and installed all new expansion compensators. We just to take safe measure, we added some expansion compensators at the chilled water plant to take some of the vibration out of the plant as well. But these are just examples that of a project where even in an existing building, you're not sure what you're going to find.
So when we talk about stack effect and we look at nature and the environment, obviously we're going to mitigate stack effect and manage it, right? We can't eliminate it, but we're going to do the best that we can with what we've got, right? But if we think about stack effect, let's look at it from worst case, right? So worst case scenario is an extremely tall building that's leaky. There's issues with the enclosure, and there's limited control on the HVAC or air movement side. And that would be in any season, right? So heating season, cooling season, regardless, right? So that is absolute worst case. But in trying to confirm and verify some of those mitigation measures, it's important to understand what that neutral pressure plane is, or NPP. So for those that don't know, obviously an NPP, or the neutral pressure plane, is no differential pressure between inside and outside, and that's determined at a certain spot in a tall building or any building. But again, there's a bunch of factors that impact that. Those dynamic factors are changed or impacted by things like air leakage, wind pressure, and of course that temperature differential outside. Where I live in Toronto, Ontario, Canada, there's obviously those northern climates see a big temperature differential. Project that Benjamin and I are working on in Chicago is of course another one. You're just not going to see that same type of temperature differential in some of the in the southern states or elsewhere.
Yeah, I think that's a really good point, that where you're located is going to really dictate how you look at your building. So when we're in a northern climate and we're working on a high-rise multifamily residential building. We like to try to confirm the stack effect calculation wherever possible. So we'll do the calculation of the temperature, and we have the great benefit in multifamily buildings of having operable windows on every floor. That can be a benefit and a deficit, I guess, depends on how you, we'll get to that in a minute. But the thing we'll do is we'll send our team through and we'll open a window and we'll see if the air is going in or the air is coming out. And we can find the neutral plane pretty quick. We see how far above or how far below we are. And I think John makes the point really well. You can't necessarily eliminate stack effect, but you can manage it. And what we're hoping to do with the mechanical systems of the building is manage it. He alluded to a project that we're doing here in Chicago together, where it's a 850-foot multifamily residential tower, very prominent feature here in Chicago that's had some stack effect issues. And I worked with John's colleague, Duncan, on this project, and we're continuing to work on it now as we're making some adjustments. But this is a building where sensor location and the reference was a very important thing. The design engineer had designed it to be on pressure control, and really what we wanted to do is have it on volume of air control. We wanted to understand how much volume is coming into the building and how much volume is going out of the building, and then be able to control it off of that. What we find a lot of times is the pressure sensors that are used to kind of control makeup air or ventilation system units in residential buildings. They're looking at a reference between a hallway and a stairwell. And a lot of times they're not even looking to the right decimal place of pressure when we're doing things in IP units. So the control systems don't necessarily have the actual control of where we want. So the location of the sensors, the reference of it, and then also the seasonality of it. A building in the summer in Chicago or in a northern climate operates differently than in the winter, and significantly different. The stack effect can flip and happen differently. We also want to look at things seasonally. So when we commission these buildings, we don't just commission it one time. We're going to commission it multiple times under multiple different temperature scenarios to understand how the systems are going to react and help set up the program. The best engineers can rarely get it right out of the gate with the settings. So a lot of times this is a fine tune of the building once it's built. You don't know how leaky it is. You don't know how drafty it is. So there's a lot of things that come into it. In this example of the project in Chicago, we wanted to understand our ability to manage the stack effect with the mechanical systems. And so once the building was fully enclosed and partially occupied, we were able to start simulating the building with load and under a sealed environment. So we had 3 different zones. We had a lobby makeup air unit. We had one that served the lower and middle portion of the building as far as ventilation makeup. And then we also had a ventilation makeup air unit at sort of the top portion of the building. And one example, we came in very cold day in Chicago, near design temperature day, and we found that the lobby unit was running 100% makeup air. And they were having a lot of issues with the elevator cars going up and down the building, getting stuck, getting jammed because of pressure, the volume of air. They had corridor doors blocking the elevator entrances from the lobby. They had vestibules, a lot of things that are best practices in buildings like this to kind of keep air from finding that path to the elevator or stairwells. However, it really wasn't working because in this case, the engineer of the designer of the system had felt that in winter I need to pressurize my lobby 100% to manage the stack effect. But in this case, they were actually making the issue worse. They were pumping the elevators full of air because they had nowhere to go, had no exhaust there. So this is an example just of different tests we ran with the systems of different things where we could see the neutral plane of the building shift with different control strategies. And so this was a great example of how we can kind of run things. We do this a lot in our commissioning procedures, is try to run different scenarios to understand and map out the whole program.
And I'd like to note on the point that Ben made about set points, right? Set points, of course, once we start doing some of that fine tuning, but it's also on the programming side, right? There's a lot of PID tuning. There's a lot of background programming that happens, and those adjustments need to happen through testing. Tall buildings need commissioning.
And that's a great point that, you need to be looking at the trends at a level where you can see if a valve or something is hunting, because it's trying, things happen very dynamically in a building that are this tall. So you can have, like John mentioned, PID loops that are just way out of tune. You can see a valve fluctuating every second in some cases. So you want to be doing a lot of your commissioning through trend analysis and data analytics, which we'll touch on more here in a minute. And as I mentioned, multifamily windows, operable windows can be a deficit to you, because now your challenge isn't automation, it isn't a PID loop, it's a person that has a hand that can open a window. And they can cause real big fluctuations in your building. And this is an example of a building where we had odor complaints from cannabis or cigarette smoke. You're not supposed to smoke in the building, but people do. And the way they get away with it is they open their window and think that nobody's going to notice. And when it's really, really cold out, because they don't want to go outside on their patio or balcony to smoke or do whatever is causing the odor, they'll open the window. In a lot of cases, depending on where you are, that can actually cause things like your toilet exhaust riser to actually draw the air in and send it to another person's unit. So we saw this, it was breaking the plane of the exhaust. The exhaust system couldn't keep up with the amount of pressure that the building was pulling into it. So there's a lot of challenges with tall buildings when it comes to people and how they live.
So I think now is a good time to talk about lessons learned, right? When we look at some of the lessons that both Ben and I have learned, both in our existing projects and of course all of our experiences, we can look at the totality of a project, right, from the design phase to operations. But when we start breaking these down, we look at some of the symptoms. We look at, of course, some of the countermeasures that we're going to implement. And you start seeing a trend, start seeing a theme. So let's break these down in real world terms as to how these things happen. So number one, design for pressurization control and include some professionals that know a thing or two about stack effect. When we start a project off, having a conversation in the design phase with the mechanical design team specifically and electrical as well, but having that conversation about a sequence of operation at which the commissioning provider has some say in, right? Has some time to review and provide some comments and feedback. But going through that, it's important that the design team actually includes a sequence of operation for this. Leaving it up to the controls contractor to put together themselves is not a good solution. They're a part of the solution, or they're part of ensuring that what we set out actually gets installed. But ultimately, having that cross-functional team early on is important, right? If we're dealing with a tall building and the team just hasn't done that before, that's fine. We're all human. Nobody's perfect, and you're not going to have experiences over everything. But ultimately, having some expertise, even albeit briefly, is clearly going to help, right? That's going to be value added to the project, right? So as I discussed, having that sequence of operation, right? Talking about what this looks like and having that spelled out in the spec allows for the team to have some success down the road, right? Now, when we get to the controls contractor, of course, being awarded, you've got a balancer and you've got a controls contractor, and you're going to go have that kickoff meeting. Having some coordination within that within that team sets the tone, right? And it starts to put pencil to paper on how we're actually going to perform this down the road. Again, that kickoff meeting sometimes can be tough, right? Because you've got a lot of folks at that table. It can be a long one, but it's clearly important, right? So the next point, when I talk about ensuring that the stakeholders understand the 5 levels of testing, if we break that down fairly quickly, number one would be factory acceptance testing. There are some air handling units, and I would definitely be an advocate for having factory tested, pressure tested, just some simple checks. The commissioning provider could or could not be present for that. But ultimately, having documentation on the factory acceptance testing for some key pieces, makeup air units, of course, air handlers would definitely foot the bill, right? Factory acceptance testing would be level 1. Levels 2 and 3 are closely aligned, but would be pre-functional and startup verification. So pre-functional equipment's on site. Perhaps it doesn't have controls, or likely won't have controls. And then of course, startup, everything is installed, normal power, and we've got controls. Okay, so 2 and 3 are somewhat conjoined. But that moves into level 4, and that's where Ben and I get heavily involved, and we write test plans for. So level 4 is functional testing, and that's the heart of what we do. We're going to verify, we're going to make some adjustments, we're going to work, hand in hand with the controls contractor, the mechanical design team, balancing contractor, and we're going to verify that these systems actually perform. Now, as related to stack effect, some systems, of course, are going to be integrated, and that's the 5th level. That's level 5, integrated systems testing. The traditional one, of course, is shut down or integrated to the fire alarm system. But again, we might have some systems that are integrated to one another as it relates to stack effect. Okay. Building enclosure commissioning. Again, underutilized in the industry. There are lots of great building enclosure commissioning professionals out there. But if we're going to do all this great work on the mechanical systems to try to mitigate stack effect, again, a leaky building is just going to make our life miserable, right? And if it's a leak down in the vestibule or in the lobby versus a leak in the penthouse, those have different effects on of course on stack. But again, having a tight building is important, and testing to ensure that it is tight is a part of that commissioning process. So when we talk about developing a testing, adjusting, balancing plan, a TAB plan, that is also something that is missed on a bunch of projects, and that gives the TAB contractor a vision, or at least they can provide their vision on how they're going to roll out their balancing. Because as Ben and I both know, everything else could be perfect. And if we have a balancer that perhaps isn't as strong in tall buildings, or doesn't fully appreciate or understand what we're trying to do, right? Then it's like pushing water uphill. It's going to be difficult, and we're going to run into some problems. So having a plan, they should be able to put together a basic plan, not a schedule, but here are the steps that we're going to take, and we understand that these are the zones, if they're pressure zones or however it might relate to your building. Giving them a say is obviously going to be value added. Okay. BMS is complete prior to TAB. So as I explained briefly prior to, I see this a lot, and I'm sure Ben does as well, in which we see in scheduling these things conflated. And we look at, as a tall building is constructed, those lower levels are going to be done first, or at least, in theory, ready for occupancy before the buildings on the upper levels. But we see a bunch of this in which both contractors state that they're ready, they're done. But the testing, adjusting, and balancing contractor has completed their work before, and then the controls contractor goes and makes some adjustments to some airflow stations, or does some tuning, or makes some programming changes. And then, of course, there's a recipe for a mistake. We see that happen quite a bit. And in fact, that exact same scenario happened on a very mission critical building of mine. And guess what happened? We had this building run negative, right? Extremely negative. And then last but certainly not least is, if we do commissioning and we're looking at trending, right, and we do all that great work and we do that testing, and let's say everything works out awesome. Most projects don't, but let's say everything works out great, and we have some very minor issues on our issues log that we need to work through. That's a Tuesday in the afternoon. We could simulate as best we can But again, that's somewhat static, right? We're going to trick the system to do different things. We have to do seasonal testing, right? That absolutely has to happen. And that's what Ben and I are working on our project in Chicago. But what happens afterwards? Does that mean that down the road things stay the exact same? Well, of course not. There are changes, base building controls changes that happen down the road. And if you're not set up for it using either your BAS, creating trends or specific alarms, then having an analytic system clearly adds some value in confirming whether or not down the road you're having a stack effect issue that's obviously causing or would cause a negative or would have a negative impact.
Yeah, I'll add to that point, John. The importance of understanding that the tuning and setting up of these buildings is a long-term endeavor as opposed to the typical, you know, commissioning project you might have where you go and you do your commission, you're maybe there through the warranty period to resolve some issues and you leave. In an office building or a multi-family building that are tall, it could take years for these to be built out. To get the floors of the office building to 75% built out, the system is going to operate differently at day one than it is day 600. And especially when you get to multi-family condominium buildings, they have to sell the units to people. People have to come in and move in and buy it. It's a long process. We see many years before a building could be even close to 100% occupied, even in rental markets. And so there's a lot of need to keep going back and recommissioning or retro commissioning, fine tuning, adjusting. And there's a mindset you have to do when you're doing the handoff instruction to the owner for and the training element is to let them understand that. They may not be experienced with operating a tall building. So you need to help train them and understand that you're going to have dynamic process here.
So we've talked about the design and construction side, but obviously this is on the operation side. When we have occupancy, this is obviously a critical stage of any project. So if we're looking at this on the new construction side, we need to think about how this building is going to be maintained. Now, no commissioning presentation would be complete unless we talked about training. And the way we used to do training is having folks in a room, of course, and having that subject matter expert speak to that piece of equipment or system. And that's always going to happen. Now, of course, it's been happening virtually, but ultimately having a document is great. But of this generation, and most folks don't typically look at those manuals. So if they do, it's usually reactive. They've had a problem, and it's definitely not proactive in preventing that problem from happening in the first place. The operations staff or operators or building maintenance staff, they have an extremely important and difficult job. But to make things easier for them, having those training sessions recorded and having those available and having those as an onboarding package down the road, project after project has proved much more valuable than the actual process itself, right? Having that recorded session gives everybody the opportunity to watch those. And every if you don't know anything about me, you would know that I've watched a bunch of YouTube videos, and if I need to fix something in my house, then a quick video goes a long way.
And John, I'll add to that comment on video recording. It's really critical for the commission agent to be part of a lot of the training that's happening, because when you're testing things and you're setting it up, you can explain that. A lot of times the manufacturer or contractor testing is missing that element of, this is what happened when I tested it. This is the alarm that you're going to see in your automation. This is the information you're going to get from the machinery versus this is what I'm going to see on the thing that comes to my phone. So your participation in training is really critical.
And some of these systems are highly complicated. So is everyone going to understand 100% of everything that's been said in 45 minutes? No, that's unreasonable. So again, the value in having these recorded so that someone can watch them down the road as part of their internal training process or onboarding package is extremely value added. Right? So the next one, of course, is understanding exhaust versus fresh air, right? That's down to the fundamentals. Now, anybody within the ASHRAE umbrella, or anybody tied to ASHRAE, is going to know that. But building owners, operations folks, contractors, they might not know that as well. So having an understanding of the makeup air versus exhaust and quantifying those in a dynamic way through flow stations or what have you, is going to be our measure for success. Um, BMS or BAS and BMS graphics. So if we want to have some long-term success, then that's definitely something that we can do, right? We have the technology. This is already readily available. We don't need analytics or anything, extremely fancy, if you will. But again, if we're going to have those sensors, we could easily create a graphic that outlines those zones, or potentially provides some kind of red is bad, green is good, as to whether or not this building is within range, right? We're going to have some level of stack effect, but having that set up is not a lot extra, and it gives some comfort to the operations staff, knowing that on any given time, you could even set up a trend for it, right? Easily, to say, here are the pressure sensors, here's our delta P in these specific areas, and here's what it looks like. Seasonal testing, right? We have to do that. Ben mentioned that earlier. Again, we could have a really good idea as to what's going to happen in, June, July, August. But if it's a infiltration issue, we're going to have to go through that in, January, February, in those colder climates. We're going to see that bigger delta T, and really see that stack effect, creep up. Okay. And then, of course, handoff from construction to service, to the service side. This is definitely an area that is missed. I know Ben and I were talking about this at length, and I'll let him, of course, speak to his experiences. But having that handoff with the appropriate documentation, and of course, having a commissioning provider provide their background and ultimately their testing documentation, definitely helps as well.
Yeah, that's a good point. With tall buildings, the handoff is really, really critical, because the person that's usually, in most markets, control companies, that's programming during construction is not going to be the same person that's going to be servicing and maintaining the control system after the project's been handed off. And so making sure that they understand what they're getting into, they understand what the sequences are about, and they understand how it's working is important. We see way too often at the end of a project, the commissioning is getting ready to happen, and the controls aren't ready yet, and they put everybody, they solve a problem of not being done with controls by just putting more people there, and just make things more chaotic. And so again, as commission agents, we don't have the ability to control all of that, but we do have the experience to know that it's going to happen, and to try to see the warning signs of where we can try to get ahead of it and make sure people are meeting the benchmarks of the milestones of that, to be able to do our job and finish the polling. So we find that one technician is going to write a sequence completely different than a different technician, and a lot of times you can get garbage in there. You can get dead points. You get a lot of things that we spend a lot of time in the commission trying to figure out and reverse engineer out. And so that finishing line to the service agreement side is very, very critical.
Okay, so here's a fun one. When we expand on some of my experiences, this is a building in Toronto that I was brought into. Not terribly tall building, 21 stories, existing building, in which they were definitely struggling. It was retail on the lobby or on the main floor, and there was a bunch of different vendors, retailers, that were complaining, rightfully so, that they were extremely cold in the winter months. It had revolving doors. It did have some other kind of man leaf doors, but ultimately, what they tried to do on their own, and you can see here by this graph, for some of those folks that would prefer in Fahrenheit. You can see that we're close to freezing temperature, 5.2 degrees Celsius outside air. So not terribly cold. But what they had actually done to try to mitigate this is they basically said that that glycol reset schedule would be negated entirely if the air handler that was serving the lobby, if that heating valve was beyond 20% open. So if it went beyond 20, of course, they just went straight to 85C water. And that, of course, made everybody else in the building quite warm. Um, that was their countermeasure for this. And they actually had a lobby heat mode. You can see that just above the red box. And that, of course, was activated again when it went beyond 20%. So there's lots of folks that will come up with some strategies. In this particular case, this one just clearly did not work. It didn't really have a huge impact on making people comfortable in the lobby. And of course, it used an excessive amount of natural gas on the boiler plant. And clearly didn't have the impact that they were looking for. So what we had done in this particular case is we went in and we took some measurements and we made some changes to the makeup air units. We quantified exactly with a balancer, with an air balancer, exactly what was happening exhaust wise. And there was some retail, food court, variability on that we had to take measurements on. And we were able to increase the VFDs on the makeup air and pressurize the building better. It certainly wasn't perfect, but it was certainly better. And of course, the litmus test on that was that the folks in the retail side were clearly more comfortable, and we were able to get a win on this one. Okay, so if we're looking at either BAS or BMS trending, then we should have the discussion about using that data. If it's not strictly alarm based or we're not doing something on the graphics side, then this is a perfectly sound and reasonable measure or tool in the toolbox that we can use, or that the owner of the building can use, or operations, or whomever. And that would be analytics, right? So I'm definitely a fan of using analytics. There is a ton of capability in insights that can be generated. So if we look at analytics at a high level, it's taking that data, right, that might not otherwise be reviewed or looked at, or at least retroactively might be, but having some hardware on site and sending that information to the cloud, right? Have it go through a firewall, have it go to the cloud, and have that data constantly analyzed. As commissioning professionals, if we were going to do this, it would take us a lot longer to find it, right? And in this particular case, we can continue the monitoring process of this and, look at this just as a stack effect or a tall building issue, right? Have those insights generate, have that information come out in a series of reports, or come to your phone if you really need to, but allow the system to do a lot of that heavy lifting, right? You can develop, rules around whatever you really want to look at. But if we're looking at pressure and we're looking at temperature, then we can clearly set that up easily with analytics.
I think, John, one of the things that's going to be a permanent outcome of the pandemic state that we've been through is that our access to data from buildings remotely has just exponentially gone up. And I'm hopeful that's a thing to say, because it's a lot easier to try to get people talking to analytics once they put these platforms into remote capabilities. So this is definitely a very, very powerful tool.
So to Ben's point, I mean, the system can look at every point, right? If it's logged every 5 minutes, or if it's on change of status, whatever it might be, right? Like, this is one simple air handler, and this could equate over the course of, let's say, half a dozen air handlers over the course of a year. This is 20 million points, 200 million points on the entire system. I mean, we all recognize that the data that's there. but we don't really do a lot about it, right? We could get some alarms on it when we absolutely need that. And I know there's some folks that might disagree with me, but at the end of the day, I'm a fan of using that data for the better. And it's not the perfect fit for every building, but there's clearly going to be some advantages in setting up this system so that it looks at this in a more critical way, right? We can be notified of an issue or an insight on as it relates to stack effect, but it also is a tool in our tool belt for the commissioning process. You know, Ben and I love using this in our projects for the very sake that it allows for a more complete commissioning process, and we can watch and confirm how the system is reacting in an ongoing live way beyond what the typical control system can do.
And to add on to that, John, even existing buildings, the excuse for years has been our server can't handle the data. We can't store trends for more than 3 days. Now with the analytics in the cloud, you can save those millions and millions of data points without impacting their operations or forcing them into an expensive front end or server upgrade. So there are benefits, and it doesn't cost that much to do this, to store that much information, but the power of it is really incredible.
Yeah, and I had a client that said, "How come we didn't have this problem a few years back or last year? How come we didn't have this problem last year?" Well, without the data, I mean, we're typically most buildings don't save a year's or 2 years worth of data. Sometimes I'm lucky to see a month, or a few days. That's more typical. So again, if it's on the cloud, then yeah, we can always look at that and we can see some of those pesky issues that might creep up. Okay. So again, with analytics, we could set up really straightforward KPIs, right? And again, we're going to look at this constantly. There could be some reporting on it because 1 month, even a perfectly commissioned building, is going to see some changes over time, and rightfully so, right? Operations staff are going to make some changes. They're going to do their own tuning, but it might actually happen in which a controls contractor might they're human too. They might make a mistake and negate some of the features that we're trying to preserve. And if we're not looking at it constantly, then that's how things go sideways, right? So having some reporting, some fairly straightforward KPIs as it relates to the HVAC equipment makes a bunch of sense. So when we talk about this in a nutshell, right? Sampling for a lot of the equipment, um, especially terminal units, right? We see a sampling strategy or a statistical sampling strategy, and that's fine, but that's not, that's the minimum, right? And we understand and appreciate that we can't test every single VAV box or every terminal unit in a tall building or in most buildings. So having a sampling strategy historically has been the only thing that we could do. But with a base automation system that's looking at these or using analytics, we can look at set point versus actual. We can look at other very basic information and confirm whether or not there's an issue. Do we have a damper issue, right? If we're looking at return air, mixed air, supply air, outside air, exhaust air, if we're looking at all of those things and something's not quite right, then that's of course something that could an insight that could be generated and we can do something about, right? But one of my bigger pet peeves is that the traditional commissioning process, a sampling strategy is typically the best that we can do historically, right? Analytics allows for us to look at everything all the time. Okay. The other thing that kind of that bugs me about the traditional commissioning process is that, as stated, we look at something at a certain point in time, and hopefully we're allowed to test those systems at that given season, right? Or at least their design season, so seasonal testing. But that doesn't always happen, and it doesn't mean that's going to stay that way. So having something in your back pocket that's looking at this all of the time clearly is going to add some value, and we're going to prevent some issues from happening, keep folks more comfortable, and of course mitigate a bunch of those issues that happen with buildings with poor or severe stack effect. BAS programming and sequence of operation changes afterwards. So again, that's going to happen. We want to ensure that any of those measures, any of those overrides or set points as they're being locked, that can be temporary, right? But it has to be temporary. If we're not keeping, or at least we don't have something in place to keep everybody honest, then that's how things go sideways. And it's not just to stack effect. That could be any system. And I know, of course, Ben and I have, been asked by a lot of owners and a lot of folks to say, I thought you commissioned this. And we say, well, we did. We did a great job. I looked at absolutely everything. And yes, we made some changes. We had to do a little bit of tuning. We had some hunting issues here, or statuses or points where we're missing here or there. But it went really well. I'm not sure the reason why the system's working, or at least not working this way afterwards, but clearly, Ben, you can jump in on this one.
Yeah, absolutely. I mean, a lot of times we get called back, and keeping your documentation is very important. The time, the dates, the information that you did with your commissioning test, because yeah, we do get that critique a lot. And a lot of times it's just things have changed. Somebody might have changed it. Yesterday, I went to a project where it was actually a maintenance issue, and they thought it was a construction issue, but it was something that hadn't been maintained properly, and it shut the system down, and it had nothing to do with how we did it. It just didn't get set up and maintained correctly after we commissioned the project. And so, yeah, understanding that there's going to be operational changes are important. As a commission agent, you want to make sure you're covered. And when you hand off your final report, it includes the level of detail of where you left it, what was the sequence that you left it at. So if a set point or something has changed, you don't really become responsible for doing that. But again, hopefully you don't come into that situation if the operators have been trained, they understand that, they know how to look at alarms, and they can handle it. It definitely depends on the type of project you're working on, with the skill level of the operator's building.
Yeah, for sure. And if we look at the monitoring based side of this, right, analytics, of course, is certainly in that, right? If there's an energy management system, or there's something else that's looking at this in the background, I'm definitely an advocate for that. Because the other interesting point that I'd like to make, and this might be a little controversial because it might upset perhaps some contractors, but there are a lot of issues that go unnoticed during the warranty period, right? There are a lot, and of course we're talking about some of that tuning that needs to happen during that first year or beyond for occupancy. That's normal. That's reality. That has to happen. But there are a lot of issues, again, that go unnoticed, and that's because there's not oversight or insight into those issues, right? It was a freak thing that happened on 1 week over a few days, the right enthalpy or whatever. It doesn't matter. It just, having a system that's looking at this, if we're looking at peak performance long term on any of our buildings, having some insight constantly on an ongoing basis clearly is going to provide value. And having an analytics platform or some type of platform, monitoring based platform, could be whatever, is clearly going to add a significant amount of value to try to find them. So that kind of leads me into my last point on ongoing commissioning, right? If we look at tall buildings, specifically, a lot of these issues, a lot of these issues might not actually bear out right away, right? Some changes down the road, maintenance strategies. Hopefully, it doesn't happen during during its life. But if it does happen, again, these could be things that happen down the road. So I'm always going to be an advocate for ongoing commissioning, and that's just predetermined testing at intervals of time to ensure that the building stays at its optimal performance. Now, there are definitely best practices out there. And the quick version is, if we're interested in making our buildings perform as per their intent, then we should be interested in maintaining that way. That's on the onus of the owner, the operations staff, facility manager, property manager, whomever has control over that side. Some of that ongoing testing can happen through analytics, through boots on the ground. But I'm definitely going to be an advocate for staying on top of that. Study after study shows that our buildings, in general, like you said, study after study shows, somewhere around 20-25% of our buildings, or at least the energy that those consume, can be absolutely removed, right? We could do a lot better with the majority of our buildings. So when we talk about an analytics platform, this is a typical dashboard. Again, there's lots of different dashboards available, but what I want to focus everyone's attention on is the money side. Now, as consultants, and I think most folks that are attending and watching this, it's tough to provide what the potential savings or what the impact is of a particular measure, right? So if we say we're not quite sure how much this stack effect might be causing people to be uncomfortable, sure, we're going to have a comfort impact on that. But there could be other aspects that are financially based, right? That are causing excessive amounts of waste on our HVAC, or on our HVAC in our systems. So with this data, the system can do it a lot faster than any one of us can, and then of course much cheaper. Having that ability to look at the dollar value of what a potential insider issue is creating, as it looks at the duration of that issue or that insight, versus what the expected consumption is of that issue. So the quick version is, having some insight on the financial side is clearly going to have an impact for the decision makers as to whether or not they do something about that problem. Because in reality, if folks are a little uncomfortable in some locations, some people might say that that's acceptable. But if they're not, if we can't quantify with a decent amount of accuracy, then it's clearly going to be an opportunity that is missed, right? Having this is a really cheap and easy way to have eyeballs look at the financial impact of these systems.
And to add on to that, it's also a helpful way for people operating a building to prioritize things. Sometimes you'll leave things unfixed, not realizing what the impact of it is. So you can look at things on a measure by measure level and understand the importance of it. And things can have a pretty substantial price tag in tall buildings. They tend to be pretty expensive buildings to operate and run. So there's definitely a great advantage to having some insight like this. With that, I believe that concludes our presentation. It's been a pleasure to present to you virtually, audience. And John, it's been great time putting this together with you.
Yeah, you as well. No, this is great. I hope that folks enjoy the content, and of course, if there are any questions when this when this is viewed, please email both Ben and I directly.